Okay, hi. This is grade 12 physics of lesson 3 means chapter 3 about fluid dynamics or fluid mechanics, which including fluid dynamics and fluid statistics. Or before we start these classes, please don't forget to join us or like this page to get the notes and the lectures at any times concerning grade 12 physics. And now we start the lessons, buoyant forces and Archimedes principles. What buoyant forces is the force that exerting by fluids on solid objects that immersed or submerged in the objects. Now buoyant force is upward force that exerted by fluid on any immersed object in it, means in the fluids. Now the questions, when does the buoyant force comes from? The buoyant force occurs because the pressure in fluid increases with depths. When we move to the depths of the fluids, the pressures increase and the force that exerted by fluids on the immersed solids is high. This means that the upward force on the bottom of an object in fluid is greater than the downward force on the top of the object, or the upward pressure on the bottom surface of the submerged object is greater than the downward pressure on its top surface. This means what we know from the definitions of the pressures, from the definition of pressures, which is defined as the rate of the force per cross-sectional area. That means pressure is directly proportional with what these forces that exerting by the fluids. That is why we say when the pressure increase, the force increase, because they are directly proportional. Means high pressure means higher forces that exerted by fluids, and the low high area means low, or surface area means low pressures, because they are inversely proportional. From the definition of the force, the pressure, force over area, means force pressure is inversely proportional with the surface areas. Now, to see these effects, consider the cylinder of the heights whose top and the bottom ends have an area A, which means both the area of the surface area or the cross-sectional of the up and the down of the bottom and the top surface of the cylinder is the same. Means both the surface area of this cylinder at the top and at the bottom is the same, and which is completely submerged in fluid of density rho, as shown below here. This is the density of the fluids. The density of the fluid. These solid objects are immersed in these fluids at height h's, and then after it is depending on the depth of the fluids, means the h2, this is the height from this point to this point, minus the height from this point to this point, means this height. And then after, the fluid exerts a pressure P1, means the pressure P1 at the top. This is equals to the density of the fluid times the gravitational acceleration and the height. This means H1, the H1, the top parts of the fluid at the top surface of the cylinder. And the force due to this pressure on the top of the cylinder is F1, means from the definition of the pressures, as it is the rate of the area, the force over area, means the force per area, and it is given by this pressure, means already we define here. And then after substituting the value of these pressures or the mathematical equations or expression for pressure into these equations, we obtain or get these results, and it is directed downwards, as we show from these figures. It is directed downwards. Similarly, the fluid exerts an upward forces on the bottom of the cylinder equal to this, which means it is directly proportional with the force at the bottom surface of the cylinders, and this is the product of the pressures and the area. We can substitute this H2, means this height, as we observe from these figures. Now the net force on the cylinder, since force is a vector quantity, we can find the resultant forces. The net force means the resultant forces. the resultant. Which resultant forces? The two forces F1 and F2. As we know, it is a vector quantity. The first force is downward. This means, as we know from vector algebra, it is depending on the position on the y-axis, means negative y-axis vertical. This is upward, the positive y-axis. Therefore, the net force means F2 minus F1, the difference between these two forces. The net force means the so-called the buoyant forces that exerting by the fluids on the solid object that immersed in this. And then this is equals to F2, F1. Substituting the value of F2 and F1 that we discussed previously, we can substituting the mathematical expressions or definition for these quantities. We can find factoring out the constant terms. That means what? The density of the fluids and the gravitational acceleration is constant. Thereafter, what is the different or the varied variables? Means H2 and H1. We can find the difference between this that we obtain here. This height that covered by the solid immersed in the fluids, and then after this implies this, and then after the buoyant force is equals to change of H, means delta means change, the difference between these two heights. And then after we obtain V, means the density, that is the product of the surface area of the cylinders and the height, length or the height, the difference between these heights from this point to this point, and then after we can find this expression for buoyant. MF means what? The mass of the fluids, that is the product of the density and the volume. You know, density means mass over volume. Just using the simple mathematical expressions, we can find the mass of the objects as the products of the density and the volume. Then after we left with G, and then after substituting this is the weight, means what? This is the buoyant forces that exerting by the fluids, and we can simply rewrite this is the mass of the fluid displaced. The mass of the fluid displaced means when the solid is immersed into the liquids or the surface, the fluids, then after the fluid is displacing, and the volume or the space that's left by the fluid is occupied by these solids. That's indicating what? This. And this mass means the amount of the substances or the fluids that leaving the object. The space or the volume of the fluids is equal to the volume of the displaced fluids. Mass times the mass of the fluid times G, means the gravitational acceleration is the weight of the fluid, which takes up a volume equal to the volume of the cylinders. Thus, the buoyant force on the cylinder is equal to the weight of the fluid displaced by the cylinder. That is what the so-called Archimedes principle. This result is valid no matter what the shape of the object. Its discovery is what? Credited to the Archimedes, which lives in these years, and it is called Archimedes principle, that relating the buoyant forces with the buoyant force with the weight of the displaced fluids. And this is the buoyant force on an object immersed in a fluid is equal to the weight of the fluid displaced by that object. This means the mathematical statements of this Archimedes principle, which relating the buoyant force with the fluid's weights, the weight of the fluids. And then after, as we know, this is totally submerged objects. We can characterize an object whether it is floating on the fluids or whether it is immersed or sinking into the fluids, or it may be some parts of the solid or that immersed or submerged to the fluid is being in the surface in the fluids or on the top of the fluids. Now, when an object is totally submerged in a fluid of density this, the volume displaced or displaced volume of the liquid in the fluid is equal to the volume of the object, as we discussed before. The magnitude of the upward buoyant force is equals to this, that is the definition that we was right before. The weight of the object with mass m is this. This means mass times the gravitational accelerations, and we can rewrite this what the definition of mass that we was right mathematically in the above expression. The net force on the object is the difference between the buoyant force and the gravitational force, means the weight. And we can substituting the value of the buoyant force here and the weight of the objects, and then what the constant values, unvaried value, since the density, the volume of the fluids and the volume of the object, we can take as v of the object again in this fluid, whether v of the object or v of the fluid, because they are equals. Then after factor out the common terms, then we can rewrite these equations. Here this is v of the object is equal to v of the fluids, the volume of the fluid. They are equal. That is why we take v is v of the object, because they are equal. Then after, the gravitational acceleration is constant at both sides, in both equations, and then after we factor out only the difference is the density of the fluids and the density of the solid object that immersed in or put in the fluids. Then we can factor out this equation just like this, and then after we will find the net forces. The net force means the force, that's the difference of the forces between these two, the buoyant force and the gravitational forces. And then we can find this equation. Hence, now before, when we start these topics or these chapters, we will discuss how the density of the fluids is affecting the properties of the fluids. Now, whether an object is floating or immersing or sinking into the fluid or moving or floating on the fluid, it depending on the density of the object as well as the density of the fluid. The object means the solid object that put in the fluids. Now, the object or the density of the object is less than the density of the fluid, means what? The gravitational force or the weight of the object is less than the buoyant forces. That means the forces that exerting, upward forces that exerting on the solid object by the fluid. Then unsupported object accelerate upwards. Upward, it cannot sink, and it is floating or moving on the surface of the fluids. Now, if the object or the density of the object is greater than the density of the fluid, this means what? The buoyant force is less than the weight of the solids. Then after, the solid is what? Immersing or sinking into the fluids or the liquids, whether it is water or oil, whatever it is, whatever you like. Now, in this case, then the unsupported object sinks, means sinking or submerged totally into the fluids. Now, if the density of the object and the density of the fluids is equal, this means what? No net forces. No net forces. The net force is zero, means the buoyant force and the weight of the solid is equal. They are balanced. Then they are at equilibriums. At equilibrium. When an object is at equilibrium, it is at rest. There is no acceleration, means when we are looking, we think from the perspectives of the dynamics of an object. Now, these two forces are equal, means the net force is zero. The net force is zero means an object is at rest or at stationary or moving with constant velocity or speed, whatever it is floating on the fluid. Then the object remains in equilibrium. It can be anywhere inside the fluids. Anywhere inside the fluids. Therefore, the direction of the object submerged in fluid is determined by the density of the object and the fluids. The direction of the object means what? In this case, in this context, in this fluid dynamics or fluid statistics, an object is what? Whether it is immersed or moving into the solid, the fluids, or floating on the fluids. Floating on the fluids. Now this, the other is floating. Floating object means, now consider an object of volume this, the volume of the object, density of the object less than the density of the fluids. The density of the fluids. In static equilibrium. What does mean statics means? Static equilibrium. not from this perspective, from dynamics. When you discuss about the dynamics of an object is at equilibrium. At static equilibrium means it is at stationary. No forces, no net forces are exerting on object. An object is at rest, or an object is moving with constant velocities, or uniformly motions. Now an object is in static equilibrium floating on the surface of a fluid. That is, an object is only partially submerged. In this case, the upward buoyant force is balanced by the downward gravitational forces acting on the objects. Mathematically, it is given by the buoyant force is equals to the weight of an object. Means you can substituting the value of the mathematical expression for buoyant force. You can equate these equations, the value of the buoyant force and the gravitational force, substituting these mathematical equations or explanation for this. Then after using the ratio of an object, now this means how we get these equations. Now the density of fluids, the gravitational accelerations, the volume displaced is equals to the density of the object times the gravitational acceleration times the volume of the object. Then take the ratio of the displaced object, the ratio of the volume of the object, times the density of the fluids, both sides of these equations. Now again, the volume of the object times the density of the fluids. From these sides, we can cancel this by this. Again, from these sides, the volume of the objects. Now in these sides, what we have? The volume of the displaced fluids and the volume of the objects. In this case, the density of the object over the density of the fluids. The volume is cancelled before that. From these sides, the volume of the object is cancelled, and from these sides, this density is cancelled. So as the rest, we can find these ratios. Now this equation shows that the fraction of the volume of the floating object that is below the fluid surface is equal to the ratio of the density of the object to that of the fluids. Okay, next lesson is fluid flow, means the kinematics of fluid. If there is any questions or any doubt, you can put on the comment. Have a nice time. Goodbye.